So I was reading the CV of Dr. Hewat Menkar, and Dr. Hewat holds a PhD in environmental economics from University of Pretoria, South Africa, and a master's degree in agricultural economics from Alma University. There she lectured economics courses and was involved in preparing strategic and action plan documents of the university. She was also postdoc researcher at University in South Africa. Some of her research experiences include crop diversification and nutrition security in sub-Saharan Africa, land use decision making under uncertainty using climate change on agricultural production and carbon storage functions of forests by God. तो कट रहा है क्या? हाँ?
कट रहा है सर, कट रहा है।
अब सही हो रहा है? अब सुनाई दे रहा है?
अभी आ रही है आवाज।
Okay. Now we are. It will take time. Hi, it's connected. It's connected. Are you able to hear me well?
Yeah.
Okay. So she was also postdoc researcher at University of Johannesburg and Tasmania University of Technology in South Africa. Some of her research experiences include crop diversification and nutrition security in sub-Saharan Africa, land use decision making under uncertainty using dynamic optimization framework by considering the impact of climate change on agricultural production and carbon storage functions of forests, then drivers of land use allocations among agriculture, forest and grassland and shrublands in southern regional state of Ethiopia, affordability and social goals of residential water tariff structure in South Africa, greenhouse gas contribution of meat consumption in South Africa, impact assessment of provision of finance and training on performance of MSCs in urban Ethiopia and women's workload, and their role in agricultural production by assessing the impact of labor-saving technologies on agricultural performance of households, especially women-headed households. A number of articles and reports have been produced from her research work. Some are published in international and local journals, including Journal of Forest Policy and Economics and African Journal of Agriculture and Resource Economics and Partnership for Economic Policy Working Paper Series, while others are under review in Journal of Feminist Economics and Journal of World Development. Together with her colleagues, she has won grants for two projects. They are financial inclusion, gender disparity and risk appetite, and micro and small enterprise performance evidence from urban Ethiopia from Partnership for Economic Policy in 2017, and a Climate Research for Development Fellowship Award for the project Crop Diversification and Security Evidence from Sub-Saharan Africa in June 2019. She had received Best Practice Award from Partnership for Economic Policy in 2018. This was the time when I met her in Bangalore and saw her presentation. Dr. Hewat's research work have been presented among others at Biennial Conference of the Economic Society of South Africa 2019, PEP Annual Conference, Bangalore, India 2018, World Congress of Environmental and Resource Economists, Istanbul, Turkey 2014, the 50th Annual Conference of the Agricultural Economics Association of South Africa 2012 and 2011 Annual Conference of the Agricultural Economics Association of South Africa, European Science Foundation, African Conference on Dynamic Interlinks between Social Ecosystems and Changes, towards a Europe-Africa Partnership 2010. Dr. Hewath is also proficient in economic data analysis using panel time series and survey data. Oh, that was quite a long one, I suppose. I did justice. Dr. Hewath, if I made any mistakes, you will forgive me. I now upon call Dr. Hewath to start her presentation.
Madam, please share your PowerPoint.
Please unmute yourself.
Yes.
We are unable to
Can you hear me now?
Yeah, I can hear you.
Okay, okay. So let me share the screen. Can you see? Can you see the?
Not yet.
Okay.
It is coming.
It's coming?
Yeah.
Okay.
It
Let
is
me
coming.
start.
Yeah, please. Yes. Yes, please.
Okay. So you can tell me when I'm left with 5 minutes.
Yeah.
Okay. So the title, sorry. The title of my presentation is Agricultural Investment in the Face of Climate Change and Climate Finance. It's a case study of the Southern Nations and Nationalist Peoples Region Forests of Ethiopia. I just want to share the experience of the agricultural investment to India from Ethiopia. Introduction. Land use and land cover change causes global warming through the emission of greenhouse gases, and it affects the ability of biological systems to support human needs. That is, it affects the vulnerability of places and people to climatic, economic, and socio-political perturbations. For instance, land use change observed in Ethiopian highlands has led to reduced surface runoff and water retention capacity and stream flow, among others. It has led also to loss of fertile soil, biodiversity, and increased landsliding and sediment loads in rivers are observed. Globally, large-scale commercial agriculture, local subsistence agriculture, infrastructure, urban expansion, and mining account for 40%, 33%, 10%, and 7% of global forest conversion, respectively. The main conversion being commercial agriculture. And deforestation in Ethiopia shows an upward trend. The distribution of forest cover in the country was 15,114 hectares in the year of 1990, and it has decreased to 12.29 million hectares in 2010. So it shows a declining trend. Large-scale agricultural investments in dense southwest tropical rainforests of Ethiopia are given to private investors to develop coffee, tea, and rubber plantations. And the forest cover in other areas of the tropics and subtropics has been decreasing. As a case in point, forest cover in India is reported to show a considerable reduction during 2007 and 2017 year, where Eastern Himalayas and Western Himalayas are taking the major share of that decline. To discourage the unsustainable land use practices, understanding of drivers of land use change is important. Absence of markets for some of the benefits of forest land uses and adverse development policies are found to be the major drivers in Ethiopia, whereas in India, shifting cultivation, rotational tree felling, diversion of forest land for development activities are the major drivers of deforestation, among others. There are a number of case studies conducted globally, and these case studies conducted in many forested areas in the world to analyze optimal land use of optimal land use between agriculture and forestry show that they considered economic values as the resource gives to forest communities. They focus mostly on both poverty reduction and tropical forest conservation only through sustainably managing non-timber forest products. But single benefit streams, especially non-timber forest products, couldn't be successful as forest use couldn't outcompete agriculture, even in many regions of the world. This is even in a case where there is forest coffee production in Ethiopia. Many studies also miss to incorporate the indirect and non-use values of forests in their analysis. The conversion of primary forest to agriculture is considered an irreversible loss, particularly regarding its biodiversity function. As a result, the decision to develop forests should be made cautiously, and this becomes even more critical as the benefits from tropical rainforests are uncertain. Tropical rainforests are one of the environmental assets, as we know, where we have only limited information. So the above two phenomena make the conventional or traditional cost-benefit analysis rules not to be appropriate to use in the analysis of optimal land use decision. In addition, land use decisions are affected by availability of funding for non-market products like carbon storage values, but the Convention on Biodiversity and Framework on Climate Change signed in 1992 and recent concerns about global warming provide many developing country governments with strong incentives conserving their forests. Carbon market is one of the major mechanisms through which developing countries would be rewarded financially by the developed nations for sustaining and improving carbon sink capacity of their forests. Hence, in this study, land use decision of agricultural investment is modeled by taking account of multiple benefits of forests, uncertainty in the forest benefits, and irreversibility of forest conversion. The objective of the study is to determine the optimal land allocation between forest land and agricultural land by comparing benefits from forest and agricultural use. In this case, agricultural use is for tea plantations. This will help to recommend for improved resource management policy. The study area, as you can see in the map, is the Southern Nations and National Peoples region, where if you see at the left corner, there is what it's called a Sheka forest, where it is dominated by primary forest. But I'm showing the general Southern Nations region as it is interrelated in different socio-economic and population, many aspects, many issues in Shaka are related with other aspects of SNNPR, the southern regions, as it is within the regional autonomy of that region. So the Southern Nations and National Peoples region is located in the southern west part of Ethiopia. It shares boundary with Kenya in south, Sudan in the west and southwest, and with Oromia region of Ethiopia in northwest, north and east. And at the time of the study, the population size was 15 million, close to 15 million, with a density of 136 persons per square meter. And the population is forecasted to grow at 2.9 per annum. The rural population dominates this population figure, where 90% of total population is residing in rural areas. And the mean annual rainfall of the region ranges between 400 millimeter in the extreme south of the region to over 2,200 millimeter in the west part of Shaka and Kafa zones for the last 30 years. And the temperature ranges between 21 and 31 degrees Celsius, but in the minimum ranges between 11 and 18.4 degrees Celsius. So basically this is a study area, but our focus is only on Shaka forest. The analytical framework used for the study is a continuous time stochastic dynamic framework. And the decision to forest is analyzed using the threshold model, where incremental forest conversion to agriculture is considered, and the technique used is dynamic optimization. And the model, this is the dynamic optimization model. It chooses the optimal amount of land to convert from forest into tea production by looking at the forecasted benefit streams from forest and tea production, tea produce, that means. So the benefit function for forest or the return from forest products is assumed to follow a Brownian or Wiener process, where and total benefit from the land is summation of benefit from forest and tea production, where TB is total benefit resulting from benefit from forest and agriculture. And okay, here. And the study area's annual flow of net benefits is the sum of agriculture and forest benefits, as you can see in the formula. And the solution to the optimal choices of the two land uses is found using the Bellman optimality principle. So the total benefit or the value function in the area is, as you can see in the formula, the maximum value of net return, the discounted net return from tea production and discounted return from forest production, where the last term shows the discounted term of expected return from agriculture and forest. Maybe I don't have to dwell more on these formulas. I don't know if there is a question, I might explain it better later. So after solving this, the Bellman optimality equation, the critical benefit curve is derived. It is an inverse relationship between agriculture, return to agriculture and return to forest benefits. The next is data and model parameters. The Atlas of the Ethiopian Rural Economy was used to get information on biophysical characteristics, accessibility measures, rural demographic characteristics, and farming practices, and productivity of land with different qualities per hectare, cost and benefit of tea production, inflation, price of tea, cost of production, loss of net revenue due to climate change and temperature are gathered. Parameter values for loss of tea production from climate change are found from studies conducted previously in different parts of Ethiopia. And per hectare forest benefits in the study area are found from previous contingent valuation studies in the area. And the forecasted temperature for 50 years was calculated from the following models. Prices of carbon dioxide was also derived from these global models, and data from woody biomass was used to construct our map. So the result, The figure shows the estimated critical benefit curve, an inverse relationship between benefits from forest and agricultural land use. As you can see, when area under agriculture increases, the forest benefit decreases. So their relationship is inverse. It's obvious. And the two curves show the different benefit curves for different uncertainty values. So this is what I just explained earlier, but okay, and in the following table, the table 2 and table 3 show optimal forest stocks when the effect of climate change on tea production is considered, and the other tables show when it is not considered, and the discount rate used was 5%. So in this figure, we can see that optimal forest stocks without carbon storage values of forests, and as I have said earlier, when effect of climate change on tea production is considered. So as you can see, when uncertainty value of the, I was supposed to mention earlier, uncertainty value calculated was 0.166 and the trend parameter is 0.025. So when we look at those figures, the optimal forest stock that was supposed to be is 217,945 hectares. But in actual case, the existing forest is 107,000. It means with the existing uncertainty and the trend values, the existing forest stock is not the optimal amount, and further deforestation should not be allowed. And when we take lower values of the trend and uncertainty parameters, the recommendation is to deforest more. As you can see, the zeros are complete deforestation. So you can see that how optimal decision of land is sensitive to assumptions of trend and uncertainty parameters. The next one, this table shows the optimal forest stock when carbon storage values are considered. As you can see, the recommended forest stock values are higher compared to the previous table. This is when we consider carbon storage. That means forests are becoming more valuable. So this shows the importance of incorporating different values of forests when we deal when we start analyzing land use decisions. This one is when this table shows when effect of climate change on tea production is not considered. That means, as you know, climate change impacts agriculture. That means by decreasing output. But now if we assume that it is not going to affect the production of tea, it means tea is going to become more profitable compared to forest. So the recommendation is, as you can see, to deforest every forest every forest land available, and this also has implication for policy. The next, this table 5 shows the same thing that means when climate change effect of climate change impact on tea production is not considered, but when there is carbon storage values of forests are considered. As you can see, the forest stocks are more than the previous table. Actually, the previous table shows complete removal of forest, but this one, when we consider carbon storage, it shows that the optimal amount of forest stock is positive or higher. The last table shows the sensitivity of optimal forest stocks to different discount rates. As you can see, when discount rate increases, when it increases, the amount of forest stock, the optimal forest stock that analysts recommend decreases. When you look at 10% discount rate, it's without carbon storage. So we ignore the carbon storage function of forests, and the discount rate is high. So the optimal solution will be to recommend to remove the forest completely. At least with carbon storage function, when the discount rate is 7, there is a recommendation of some kind of forest stock. When without optimal forest stock without climate change, without carbon storage function, with carbon storage function, the whole thing, this table, what it shows is the combination of the previous table, but when the discount rate is changing. So when we look only at the discount rate, sensitivity to, the forest conversion rate to sensitivity to discount rate, it means higher discount rate is leads to deforestation or complete removal in the case of 10%. And the problem is with government with social planners, when they evaluate projects, usually they use higher discount rates, which is common, especially in developing countries. They put less value to the future and put high value to the current situation. So at the end, it is a suboptimal solution. So the conclusion is the land use allocation decisions are sensitive to considerations of uncertainties, reversibility, and externalities associated with conversion of land resource use, climate change, and discounting future values. And when benefits from forests are treated as stochastic outcomes, optimal forest stocks are higher than the deterministic framework. That means additional land under agriculture is recommended in the case of deterministic framework or the traditional cost-benefit analysis framework. And finally, suboptimal decisions may also result from considering compensations for the positive global environmental externalities of carbon storage in forests. So incorporating carbon storage functions in cost-benefit analysis is very important to save the livelihoods of forests communities. Thank you.
Thank you, Dr. Menker.
Okay, thank you.
So would you like to take presentations are over?
Oh.
We will take the questions. Are any, is it okay?
Yes, are you speaking to me?
Yeah, I'm saying we may take any kind of questions.
Yes, okay, okay.
After all the presentations are over the stage.